Notice how this graph has a high peak here. That is called a relative maximum. And when it has a valley, it's considered a relative minimum. It doesn't have to be the lowest point on the graph altogether, because we see at the left here there's an arrow saying this graph goes downward, but it's the lowest value on an interval. Likewise, this is not the global maximum, it's just relative maximum on a particular interval, because this graph goes up, up, and away, as we see with that arrow at the right. For this next problem, we're asked to find the relative maxima or minima. Now, maxima is just plural for maximums, so here we go. The relative maxima. They are going to be where the 2 points are at the high values, and those will be the 2 points, -2, 3, and +2, 3. Where does the graph have a relative minima? Well, that will be right here at 0, 1. So a relative minimum at 0, 1. Now we have a kind of a backwards problem. They've given us the graph and they want us to write the rule, write the function here. So we're going to have f of x is equal to a graph in 2 parts. Now the left part is a diagonal line. Notice it has a y-intercept at the origin. So that will be y equals -x, and comma, it is defined for x values less than 0. We know not to include the 0 because of the open circle there at the origin. The next graph is that of a square root graph shifted up 1 unit. So the square root of x plus 1, and that is defined for x values greater than or equal to 0.